When we're comparing data, the most common method though is to compare the summary statistics. So your 5-number summaries and stuff like that. Measures of location such as mean and median are used to compare typical scores. Measures of spread such as range and quartile range and standard deviation are used to make assessments about the consistency. Now, we've done this before. We've entered data in, we've found standard deviations, we've found means, we've found modes. Okay. I'm going to show you a way to actually do this so you can put both sets of data in at once. Okay. Most of the time we've done one set of data. So in the way we've done it before, you'd enter one set of data, you'd find the mean, you'd find the standard deviation, you'd clear it, you'd enter the next set of data. I'm going to show you why you don't have to do it this way, but I'm going to show you why you can enter actually both sets of data at once. Okay. So, on your mode, I'm just going straight to the stat mode. Okay. Now, when you get here, we would normally choose number 1, which is one variable. What we're going to choose is number 2, a plus bx. Okay. Just press number 2. Good. Okay. It means you should be an expert. When I do that, you'll notice I've got 2 columns, an X and a Y. I don't have the frequency column. I've got an X and a Y column. So now I can just enter them in. I'm going to do Jane as X and then Pierre as Y. So I'm just going to enter all of Jane's, then go back to the top and enter all of Pierre's. So 45 equals 62 equals 64. Delete 64 equals 55 equals 59. 62 equals. Then go back up to the top and then do Pierre's. 84, 37, 44, 80, 74. You guys ended them all? Okay, so once you've got all the data entered in there, it's pretty much the same as we've done before. You can just hit all clear, then you go back to your stats. Now when you go back to your stats, we're still going to be using the variables, so we're still going to go to number 4, but you'll notice there's more of them in there. You've actually got the bar X, which is the mean of X. You've also got the bar of Y, which is the mean of your Y column, which in this case is Pierre. Okay. Then you've got sample standard deviation and population standard deviation of both Y and X. We're going to use population standard deviation for these, but we'll start off, let's just get the mean for, we'll just get the mean for Jane. So that's our X. So 2 equals, so Jane's mean is 57. Then we'll go back and go, I'm going to go Pierre's mean. So that's the mean of Y, 57.5. Then we'll get the standard deviation for Jane, which on mine is number 3. Gives me a standard deviation of 6. And then we'll do the same with Pierre, which on mine is number 6. And standard deviation 17.4. Which part? Okay, so have you cleared it? Okay, you go on shift 1 to bring up your stats. You go into variable. Okay, you entered in your X column, you entered all of Jane's numbers, right? So that's the mean of Jane's stuff, the X over the bar over the X. Then you got population standard deviation of X, and then sample standard deviation of X, and then you've got exactly the same for the Y's. So all the X ones are Jane's, all the Y ones are Pierre's in this case. The European 7. Some people do it so it doesn't look like a greater than symbol. Okay, so question B asks, which student had the overall better performance? Who do you reckon had the overall better performance? Pierre? Yep. And we do that because he has a higher mean. Only by half a mark, but sometimes that's all it takes to get you into university. Question C says, which student was more consistent over the 8 tests? Over the 8 tests. Jane, because she's got a... And what statistic shows us that? And it is excellent. She's got a lower standard deviation. That's how we know she's more consistent. We look at the numbers and we go, yeah, they're all around the same, and that's absolutely correct.